Hi guys, in this video we will be revisiting the idea of optimization. We have worked on optimization problems previously, however this time we'll be working with the benefit of using information provided by the second derivative. We'll also be able to use the chain product and quotient rules to potentially tackle more difficult problems. We remember that at its heart, optimization is all about finding maxima and minima points of a function. We're looking for those regions where we can maximize some output or minimize some cost, for example. To start with, let's review the steps that you want to take when approaching an optimization problem. The first and most critical step is to read the problem carefully. You really want to understand what it is that is being asked for. Step 2 is to record any information that you've been given as part of the problem. What do you know? Any facts, relationships between variables? At this point you can also be defining the variables that are involved. If it's at all possible, step 3 is to sketch the problem. Try and get a physical representation, either by sketching a graph or a curve, or by sketching what's happening in the problem in order to understand it better. We actually deal better with processing information when we can see it visually. Once you've understood the problem and you've selected appropriate variables, the next step is then to write an equation representing the quantity to be optimized as a function of another variable. It's possible that to start with, your equation might rely on more than one other variable. You need to use other information or connections between the variables to eliminate all but one. Once we have our equation representing the quantity to be optimized, we can use the first derivative to locate stationary points, which could include a maximum or minimum that we're after. Finally, we're going to use the second derivative to identify the nature of any stationary points. At times, this process might need to be tweaked a little. For example, the final step, using the second derivative, may not give us definitive information on what type of stationary point we're dealing with, and we may need to go back and look further at what the second derivative is doing around these points. We might also be asked to work out a value of the function. So for example, we might be looking at the number of products that we need to maximize profits, but we might actually also be interested in knowing what that actual profit will be. So locating the stationary point, the maximum, and knowing at what number of products that occurs is not the final step in the solution. We then would need to substitute in that value and work out what the profit would actually be from the function we've come up with.